Most people see a photograph of Lake Hillier and assume somebody pushed the saturation slider. A flat disc of bubblegum pink, 600 metres long, sitting behind a thin ridge of white sand, with the deep blue Southern Ocean breaking just beyond the dunes. But the strange part was never the colour. Pink lakes are not rare. Australia alone has dozens. The strange part was that this one seemed to refuse to change. Hutt Lagoon, north of Perth, shifts from lilac to red to grey with the season, the cloud cover and the angle of the sun. Lake Retba in Senegal lost its rose colour completely after the floods of 2022 and only got it back 3 years later, in early 2025. Esperance's own pink lake, printed on every tourist map, stopped being pink around 2007 after a century of salt harvesting and road and rail works that cut its salinity. Lake Hillier held.
In every photograph anyone had taken through drought and downpour, the same improbable pink. And in more than 2 centuries of people staring at it, exactly one research team has sequenced what lives in the water. That is the honest shape of this mystery, and it is not the one the internet sells you. You will read that science cannot explain why Lake Hillier is pink. Not quite. The broad answer has been known for decades. The colour comes from pigment made by microbes that thrive in water far too salty for anything else. Ask a microbiologist why a hypersaline lake turns red, and they will not hesitate. Ask them what mixture of organisms was producing this particular pink, and why it looked permanent when every comparable lake flickers and the confidence drains out of the room. Those questions are still open, and in the last few years the lake has answered one of them in the least convenient way possible. Middle Island is the largest of the Recherche Archipelago, 105 islands and more than 1,500 islets off the coast east of Esperance in Western Australia. These are not coral islands. They are granite domes of the Recherche and Esperance supersuites, magma that crystallised deep in the crust between about 1,300 and 1,100 million years ago during the Albany-Fraser orogeny, the collision that welded the Yilgarn craton to the crust that would become Antarctica. For most of the last ice age, they were not islands at all. Sea level sat more than 100 metres lower, and Middle Island was a hill on a coastal plain you could walk across.
As the Ice Age ended, the ocean climbed, drowned the plain, and left the granite high point standing offshore. On the 15th of January 1802, Matthew Flinders climbed that island's high point and wrote down what he saw below him. A small lake of a rose colour. He never went down to it himself. His master, John Thistle, walked to the shore and carried a sample back. Water so saturated, Flinders wrote, that enough had crystallised near the banks to load a ship, and it needed no process but drying to be fit for use. 16 months later, in May 1803, Flinders came back for that salt. His crew were dying of dysentery, and he anchored to fill a few casks from the lake. The casks stayed empty. His master reported that no good salt could be procured, where before it would have furnished almost any quantity, and Flinders wrote down the reason himself. The change, he said, had doubtless been produced by the heavy rains which appeared to have lately fallen. So the first return visit on record already found Lake Hillier broken by rain, and for 200 years nobody treated that as data. 2 men died in that bay. The boatswain, Charles Douglas, was buried on Middle Island under a copper inscription. William Hillier, whom Flinders called one of my best men, died of dysentery and fever before the ship could get out. The lake carries his name.
Lake Hillier sits in a shallow basin on that granite, 15 hectares of water on an island of 1,000, separated from the Southern Ocean by a narrow barrier of dune sand and a fringe of paperbark and eucalypt. No river feeds it, and no outlet drains it. Seawater seeps in, the sun takes it back, and the salt stays. So what makes it pink? Evaporate seawater and you get brine. First a few percent salt, then 10, then 20. Ordinary life quits early. Fish go first, then most bacteria. What survives is a narrow club called halophiles, salt lovers, which solved a brutal engineering problem. How to hold water inside a cell when the water outside is desperate to pull it out. That comes with a side effect. Cells in that much salt and sunlight take constant damage from ultraviolet light and oxygen radicals. Their armour is carotenoids, the same family of pigments that colours carrots, flamingos and salmon. Pack enough of them into a membrane and the cell turns orange, red or deep pink. Two organisms usually get the credit. Dunaliella salina is a single-celled green alga that, stressed by salt and light, floods itself with beta-carotene until it stops looking green at all. The other is a bacterium, Salinibacter ruber, which loads a red carotenoid into its membrane and lives at concentrations that would sterilize almost anything. The number you will see quoted for Lake Hillier is 28% salt by weight. It comes from a single water quality review, not a monitoring series, cited rather than remeasured by the team that made the lake famous.
At face value, that is roughly 8 times the ocean on the other side of the dunes, at or past the point where sodium chloride stops dissolving, which is precisely why Thistle found crystals along the bank. Because the pigment sits inside living cells, suspended in that water, it travels with the water. Scoop some into a bottle, and the bottle is pink. The colour is not a trick of depth or sky, it is biomass. All of that is textbook. Here is where Lake Hillier stops behaving like the textbook.
In 2022, a team led by Maria Sierra and Scott Tye published the first metagenomic survey of the lake from water and sediment collected in 2015. Salinibacter ruber came back as the most abundant bacterium. Dunaliella salina as the most abundant eukaryote, as expected, but so was almost everything else. 4,000 species detected, nearly 500 of them extremophiles. Dozens of known pigment producers, and 100 more whose pigments nobody has characterized. 112 kinds of virus. Of 21 genomes the team reconstructed from scratch, only 2 matched an organism science had already named. And their conclusion was not a name, it was a hedge. They hypothesized, they wrote, that the colour derives from a combination of these and potentially other pigment-rich organisms, and stated plainly that this work is not the final answer. All of that pink depended on one number, salinity. Hold the lake near a quarter salt by weight, and the halophiles own it completely. Let the number slip, and the specialists lose their only advantage. Ordinary green photosynthesizers, excluded for thousands of years by chemistry alone, move in and take the lake. Then, in the last few years, an extraordinary rainfall event dumped fresh water onto Middle Island and diluted the brine. Accounts do not agree on which year, which tells you something in itself. The result is not in dispute. The pink drained out of Lake Hillier, and people flying over it began reporting something blue-grey, murky, and thoroughly ordinary. Thilo Massenbauer, an environmental scientist working on the Esperance lakes, expects evaporation to concentrate the brine again, and the colour to return, on a 5 to 10 year horizon. Lake Retba took 3. So the lake that never seemed to change, changed. And nobody can tell you when it comes back, because nobody measured what would let you predict it. How fast salt moves through that dune barrier, how much rain the basin can absorb, where the tipping point sits. There is no published water budget for Lake Hillier, just one DNA survey and 2 centuries of people admiring it from a distance. That is the real answer to the question in the title. The pigment was never the mystery. The mystery is that we built a global icon out of a lake nobody was monitoring. A place inside a strict nature reserve you cannot simply walk onto. So remote that most people who have seen it saw it through an aircraft window. And so photogenic, nobody thought to ask what was holding it in balance. Lake Hillier was never permanently pink. Flinders proved that in 1803, and we spent 200 years not reading it. The lake was pink for exactly as long as the arithmetic of rainfall and evaporation held. Right now, quietly, on an uninhabited granite island in the Southern Ocean, that arithmetic is being redone, and for the first time, we are watching it happen. If you want more of Australia's stranger geology, there is plenty of it waiting on this channel.